Hello everyone. In this small demonstration, I'm going to uh, portray some differential calculus, and we'll be seeing one rule, so seen an example, and also how to derive the rule. So here we're going to see the quotient rule, and the quotient rule in differential calculus states something like that, something like this. So if y is equal to fx upon gx, then y prime is equal to f inverse x gx minus g inverse x, sorry, g prime x fx, I'm so sorry, it's f prime x gx minus g prime x fx upon gx square. So how do we get this thing? We need the proof. We're going to prove it now. For that, for the sake of simplicity, I'm calling fx to be f and gx to be g. Why? Because both f and g are the functions of x, so it really does not matter if we just keep them simplified. It would eradicate some very complicated or stuffy looking mathematics on our whiteboard. So we start. Okay. We can write y is equal to f by g. So we can remodel it and write it as y is equal to f into g inverse, right? And if I differentiate it, it should be now again we should be acquainted, because of proving the quotient rule. It is assumed in this tutorial that people are already familiar with the product rule and some basic differentiations, because that knowledge is required in this tutorial for proving the quotient rule. So if you want to differentiate a product, it goes something like this. So we are doing y prime, so differentiate the first term and keep the second term as it is, plus differentiate the second term and keep the first term as it is. So we will keep it f as it is, and we will differentiate g inverse, and while doing that, when we differentiate g inverse, we need one the derivative of g as well. So it will go like this, applying the chain rule here. Now we have to kind of manipulate it to make it look something like this, you see. So let's do the manipulation of it. We get here f prime g inverse, okay, plus now differentiating this thing g inverse prime, okay, this is prime icon. So I will get minus 1 g minus 2 into g inverse. So this can be written as, now I'm throwing some numerators into the denominators, so f prime g minus f g prime upon g in g square. Okay, if you guys are getting a bit confused over here, I'm just giving a small example. Just take let's take another function. Cx is equal to x square sine x square sine 3x square. Okay, let's make it more complicated so people can. So now if you want to differentiate this, how are we going to differentiate this? We are going to differentiate the first thing and then going to keep the second thing, and then we are going to keep the first thing and differentiate the second thing. Now while differentiating the second thing, there is a bunch of things that we need to do succeeding that. Okay, so if I show you how to do it, so we differentiate the first thing, x square, we get 2x. Keep the second thing, sine 3x square. Now we keep the first thing and differentiate the second thing. What is the second thing? Sine 3x square. What would be the differentiation of sine 3x square? Cos 3x square. Okay, dot the differentiation of this term. Now if someone was getting confused, how did we get this g prime, here you have it. Okay, cos 3x square, oh sorry, here is square, into derivative of 3x square, that would be 6x square, 6x, I'm so sorry. Okay, so that is how you get to this point, and then we're doing some simplifications over here. Now I need to make it look something like this. Okay, we see here we have a g square, and if I multiply this term above and down by g, I could get something like this, f prime g minus f g prime upon g square, right? So we see exactly, if I write it in this form, I can get f prime x gx minus fx gx prime upon gx square. Okay, now let's take an example. Let's take a small example of how to solve this. Problem 1. For example, let's take y is equal to 3. Let's take ex upon sine x square. Now we can see from over here, fx is equal to e of x, and gx is equal to sine x square. It's not sine square, it's sine x square. Okay. Now y prime will be f x prime gx minus gx prime fx upon gx square, gx square. Okay. So what is fx prime? We know derivative of ex is equal to ex, e raised to the power x, dot gx is sin x square minus now derivative of sin x square, what it will be? Cos x square into 2x. I'm writing it over here because I do not want to make it feel like it's part of the argument of cosine, into fx ex upon g square x. So it will be sine square x square. So yeah, this is how we get our, oh I'm so sorry I just ruined it. This is how we get to our final result, which is the derivative of y. So I hope this is clear, and that was all. Thank you.